Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Handling Model Drift and Performance Degradation. Handling model drift and performance degradation is a critical challenge in the lifecycle of generative artificial intelligence systems. As models are deployed into real-world environments, they encounter ever-evolving data streams, changing user behaviors, and unforeseen external factors. These dynamics can lead to model drift, where the statistical properties of the input data change, causing the model's performance to degrade over time. Understanding and managing this drift is essential for maintaining the relevance and accuracy of AI models. At the heart of model drift is the concept of data distribution shift, which can manifest in several forms. Covariate shift occurs when the distribution of the input data changes, but the relationship between input and output remains stable. For instance, a generative model trained on images of urban traffic may experience covariate shift if deployed in another region with different vehicle types and road conditions. Concept drift, on the other hand, involves changes in the underlying relationship between input and output variables. This could happen in a sentiment analysis model, where the meanings of words evolve due to cultural or societal changes. Both types of drift can significantly impact the model's predictive power and necessitate robust monitoring and adaptation strategies. Performance degradation due to model drift underscores the necessity for continuous monitoring in GenAI systems. Monitoring involves tracking key performance metrics to detect deviations from expected behavior. Techniques such as monitoring input data distributions, output predictions, and error rates are commonly employed. Anomaly detection methods can be particularly useful for identifying unusual patterns that may indicate drift. In practice, setting up a monitoring framework requires defining thresholds for acceptable performance and determining the frequency and granularity of checks. For example, in a recommendation system, a sudden drop in click-through rates may signal a shift in user preferences, prompting further investigation. Addressing model drift involves a combination of reactive and proactive strategies. Reactive strategies focus on detecting drift after it has occurred and taking corrective actions. Retraining the model with recent data is a common approach, which helps the model adapt to new patterns and trends. However, this process can be resource-intensive and may not always be feasible in real-time applications. Proactive strategies aim to anticipate drift and prevent performance degradation. Ensemble methods, which combine multiple models, can offer resilience against drift by leveraging diverse perspectives on the data. Additionally, online learning techniques, where models continuously update with incoming data, provide a dynamic approach to maintaining performance. Incorporating feedback loops is crucial for effective performance management. Feedback loops involve using predictions and outcomes to refine models continuously. In the context of GenAI, feedback can come from user interactions, expert evaluations, or additional data sources. For example, in a natural language processing application, user corrections to model outputs can be used to fine-tune the model, enhancing its accuracy over time. Feedback not only helps in correcting errors, but also in identifying areas where the model may require further training or adjustment. The deployment environment of a GenAI model also plays a significant role in managing drift and degradation. Cloud-based platforms offer the advantage of scalable resources, enabling frequent retraining and model updates. Moreover, edge computing solutions can bring computation closer to the data source, reducing latency and allowing for real-time adaptation. The choice between cloud and edge deployment depends on factors such as application requirements, data privacy concerns, and computational constraints. One of the most effective ways to handle model drift is through robust validation frameworks. Validation involves testing the model on unseen data to evaluate its generalization capabilities. In a dynamic environment, traditional static validation approaches may fall short, necessitating the use of rolling windows or time-based validation techniques. These methods divide the data into temporal segments, allowing for the assessment of model performance over different periods. Such validation strategies can provide insights into the model's adaptability to changing conditions. Another critical aspect of managing model drift is the role of interpretability and transparency. Understanding the decision-making process of AI models is vital for diagnosing performance issues and implementing corrective measures. Techniques such as feature importance analysis and SHAP values offer insights into how models weigh different inputs. By elucidating the inner workings of the model, these methods empower stakeholders to make informed decisions about retraining, feature engineering, and model modifications. The human element in continuous monitoring and performance management cannot be overlooked. Human-in-the-loop approaches, where human expertise complements automated processes, can enhance the robustness and reliability of GenAI systems. Experts can provide domain-specific knowledge, validate model outputs, and offer context that is not captured by data alone. Collaborative efforts between humans and AI can lead to more effective handling of model drift and performance degradation. Ultimately, the goal of managing model drift and performance degradation is to ensure that GenAI systems remain accurate, reliable, and aligned with user needs. This requires a holistic approach that combines technical solutions with organizational strategies. Establishing clear governance frameworks, defining roles and responsibilities, and fostering a culture of continuous learning are essential components of successful performance management. In conclusion, handling model drift and performance degradation is a multifaceted challenge that demands a comprehensive strategy. Continuous monitoring, robust validation, adaptive learning techniques, and human oversight are key elements in this endeavor. By understanding the nuances of model drift and implementing effective management practices, organizations can ensure that their GenAI systems remain resilient and impactful in an ever-changing world. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.